Okay, engineering economics. Now, this particular problem deals with alternative projects and stuff like that, comparing the best alternative and stuff like that. So, we are given two projects, A and B. And so, here, if useful life of A is 4 years given the rate of return as 15%, what is the useful life in years of project B that would make both project equally desirable, basically? So we have the initial cost of both, annual savings, and we have the salvage value. That's what I've put here as salvage value. So you can approach this problem different ways, but basically trying to bring everything to a present value, or trying to bring everything to an annual value, or trying to bring everything to a future value. So it seems like here, the easiest way is to bring everything into annual value, because we have annual savings here already. So that would make it easier, and yeah, that would make it a lot easier, I believe. But either way you go at it, we should expect the same end result. So how do we do that? Okay, so for A, let's call that A, amount. Wait, what should I put in there? Let me put maybe XA or something. XA, because I'm trying to find the annual value of project A, and the annual value of project B, and equate them, because that's the question here. Okay, so XA, so I'm trying to bring it annually. So I'm trying to see what is the initial cost if that was to be considered annually. So this is the present value because it's initial cost. So what I typically do, let's go to the engineering handbook here. As you can see here, we have the number of years, we have I and stuff, but you don't want to use these formulas right here because it's pretty complicated. So what you want to do is using the table. That's the table is typically in the end, but you want to use the values over here, and these values are actually given in the end of the book. At the well, not at the end, but over here, right? So for I, you have these values over here. So you would want to use this because it's a lot easier. So you have your years, and then you have present value given F, present value given amount, the annual amount or something like that. So we want to go that route instead of the formula route. We don't want to use the formula at all, although we could, but it's not helpful. Don't do that. That would be way too long. Okay, so let's go back here. So now my for project A, that's what I'm calling XA. I forgot what they call it, but there's equivalent worth or something like that. I can't remember, but I think it's annual equivalent worth or some type of thing. But let's call it XA. That's the annual amount for project A, the annual value, the annual worth for project A. So this is the present value. So the way I do it to basically not get confused is that I'm given P, right? So I always put P in front. I'm given P and I want A. In order to cancel this out, I would have to multiply this by P. Okay? And I have my N and I have my I. Right? So that would be over here, right here. Now, initial cost, you would have to subtract your savings and everything else to kind of see what it is at the end. Okay? So we're subtracting the savings. Now savings, this is annual savings, is already in A, so you don't need to convert anything. Remember, we're trying to bring everything into A, so into the annual. So it's already in annual. We don't need to do anything, so we can just put 16,000. Salvage value is the final value, the final value of project A, whatever that is. I don't know if it's a car or not, but that's the final value. So we are given final. Okay, we are given final. So this is you subtracting with the initial cost. So we are given final. I need A and I have F. So you see they would cancel out. P would cancel out with P, and you would be left with A, and we need A. So this is an A amount. This is an A amount, annual amount, and this is an annual amount. So you don't want to mix things up, because a lot of times what happens is you don't know what you multiplying. You don't know if you should use PA. You don't know if you should use AF. You don't know if you should use. That's probably what the confusion is for us students. I remember undergrad I was very confused with that. When do we use AP, when do we not? But the way I do it typically is that I try to bring everything, because you can't mix apples and oranges, right? So you don't want to add present values with annual values. So you would have to convert everything back to one common what do you call it, denominator or something like that. Yeah, so you're trying to bring everything. So for instance, if I wanted to do this in present value given annual, I don't know what annual is, but just let's suppose I was given annual, then I would have to put given here, like A here. But maybe we'll do an example where you could actually see it. But typically you want to bring everything into, you want to put everything in oranges and not mix orange and apples. You know what I mean? So this is already annual. You don't need to convert it to anything. Your 75,000 is a present value, so you want to bring it to annual value, and that's why you do it this way. You are given P, so you always start with what you're given, and then you don't get confused. You start with what you're given, and then you do it with like what you need. And then of course in math, if you were to cancel, you'll see that you were left with A. So that's kind of how you picture it. I mean, this is my first video explaining engineering economics, so I don't do this on a daily basis. This was, I remember this just undergrad, because I'm electrical, so I don't deal with this every day, but that's what I remember doing it that way. But so if you have any questions, just please don't hesitate to ask. Anyway, so let's keep going here. So N and then I, of course. So this is for project A, so we can go ahead and calculate our amount A. Remember, we are asked to find the number of years for project B to be equal to project A. Okay, so I have 75,000 here. Now for this particular value, AP, N, and I, N is 4 years, I is 15%. So I can go to the table and look for AP, 4 and 15%. Yeah, I don't know if there's a 15% here though. I don't remember seeing that, but we can approximate it, because 15% is between two values anyway, right? So whatever those values, we can maybe use interpolation or some type of math method. 6%, 8%, 10. Yeah, this is even, so I don't think 15 would be here. But if it was to be here, let's say this was 15. Well, okay, this is 12. I need AP, so this is AP over here, 4 years. So it's approximately 0.3 whatever. So that's 4 years right here. So in the exam, they typically give you an I that's there, that's in the table. But if you don't have an I that's there, what you do is use like your linear interpolation. So because your I is 12% here, let's go to the next one, and remember this is 0.32. okay, for I 18%. Let's see here, 4 years, 15%, I mean 18. AP is 0.37, so it's increasing, right? 0.32 to 0.37. So it's somewhere in between 32 and 37. So it's not 32, it's not 37, but it's in between somewhere, because 12% is 15%, that's the rate we're dealing with, is in between 12% and 18. So it's somewhere around there, and it's increasing So it could be 33, 34, 35. So yeah, you can use just a random number to kind of get an approximation, or you can go to the extent of using linear interpolation, which I cannot remember. Absolutely not. So I will have to do some research on that. But let's just, let's just pick a number. Let's say, for the sake of an example, let's say 0.34, because we know it's in between, so it shouldn't be that far from that anyway. So this is not exact number, but you know the point is in between that, so I can't be too wrong from that. Okay, minus 16%, I mean 16,000, that's the annual value, minus the salvage value, so that's 9,000. Again, here we go to the table again. AF, that's what we need for 4 years and 15%. Let's go back to the table. AF. So AF is here 1, 2, 3, 4 years. So we have 0.2092. Let's go, because this is for 12%, so it is not exactly that. Let's go to 18. 4 years. AF 1, 2, 3, 4, 19. So this is decreasing, right? So I had 0.2092, and here I have 0.1917. So it's decreasing, but not a lot. Again, you can use interpolation to get the exact number, but it's in this particular case you kind of don't, well, yeah, you need to get the exact number, but you can also approximate, because if you see the question, you typically is like what is it most nearly, it's not necessarily what it is exactly, but what it is most nearly. So you kind of get an approximation, and you will see that we won't be too far from the answer anyway. So let's just pick a number. It was 0.2092 for 12% and 0.19 for 18%, so it's somewhere between that, and it's decreasing. So let's say 0.2 period, because it was 0.2092, right? Okay, let's just say 0.2, whatever. Okay, I could have picked 0.19999, so okay, so let's use calculator here. XA would be, let me calculate this. Okay, so I have $7,700. Yeah, I think that's a value here. Dollars here. Okay, so that's for XA. Now let's see for B, the final amount for B. Again, if you want to get the exact answer, please use interpolation. I will have to do some research on that and remember the exact formula, but I can't remember it right now. But yeah, that would be the best route. But let's just go ahead and see what it is. So for project B, same thing as here, except that we don't know what the number of years is. So we don't have salvage value, so that would be 0. Now we have present value and we have annual savings, so we can use the same thing. So 105 AP and 15%. I should have put 15% there, minus 24,000. That's already in annual, so we don't need to do anything. Now remember, the question was for both of them to be equally desirable. So XB is actually supposed to be equal to XA, which was to be 77. thousand. So this is what we need to find, right? So just like math, simple math, we just divide and subtract. So my AP N 15% is equal to 77, right? Plus 24, and divided by 105k. So let me calculate that. 77 plus so I have 0.301 919. Okay, so I need my AP to be approximate. I mean my AP at N 15% to be equal to 0.3019 approximately. Hey, so let's go back to the table and see if you can find that. Again, we don't have 15% here, so we have to go to the table and approximate. So for 12%, okay, this is for AP, we have 0.3292. Okay, so let me write that down so you can see the approximation game that I'm about to play here. Again, if you want the exact result, you use linear interpolation. Okay, so for 12%, we have at 4 years we have 0.3292. Let's see what we have at 18%. Remember, 15% is between those two. So at 18% AP, that's close to my point 30 here. My AP again is let's see here, AP, you know, we can use this one, and that's at 5 years actually, 0.3198. okay, so this is at 5 years, 18%, 0.3198. now if you see here, it's gonna be in between these two. Now which one is it closer? It can't be more than 4 years. It can't, well, it's got to be between 4 and 5. So it's either closer to 4 years or closer to 5. Okay, so this particular value over here, 0.3019, you know, this is closer to this value over here. Wait, what is that? Okay, so it's closer to this, so I can approximately say that the number of years is going to be approximately 5 years, and I can bet you that in the question answers, you know, the multiple choice, you will have 5 somewhere in there, and you will choose that answer. You see what I'm saying? So if this was 0.32, then I will use, if this was 0.33 maybe, then I will use 4 years, right? Because the 15% is between these, and I'm dealing with a rate of return of 15%. It's between these two. The years is between these two. I'm just trying to see the AP is between these two. I'm just trying to see which one is closer to, because I know it's either 4 or 5. It can't be 4 point something, so it's either 4 or 5. Okay, so you see the logic there with engineering economics is, when you get to a point where you're not using the table, then you know something is wrong, because you have to use a table, and it's a lot. It's very easy actually. It's very easy once you get your you translate your problem into you know, A's and P's and stuff. And I'm gonna do some more examples like that. But you always want to have oranges or apples, but you can't mix them. So sometimes you will see students hesitating between, what am I going to put here? You can't put anything here because you're dealing with annual, and 16,000 is already annual value. So that's what it is. So if you have any questions, especially with the how I got the approximation, let me know. I'll do some research on linear because it's been a while. I have not even dealt with engineering economics and linear interpolation and stuff like that. But if you have any questions, do not hesitate. Please let me know, and I'll be glad to answer your questions. All right, thank you.